and I've been working in MySQL for last 5 years, and I work in this MySQL Performance Schema team, and today I'll be talking about the same. Oh, the screen is gone again.
Oh,
Okay, it's there. Right, so before we move into the presentation, this is a safe harbor statement which says whatever I'm presenting over here is for informational purpose only, and you should not make any purchase decision based on that. Right? So this is the agenda of today's talk. So I'll be talking about the need and design of performance schema. I'll talk about the instruments and instrumentations, what are those. Then I'll talk about the statistics tables which we have in performance schema. And then I'll take few use cases to walk you through how can we use performance schema to diagnose real world issues. And then we recently released MySQL 5.7 last year October. So I'll give you a glimpse of what new we have in performance schema for MySQL 5.7. Okay, so need. So the question comes, why do we need performance schema at all? So there are multiple users for MySQL database. So we have an end user which might have a question why my particular session is stuck. We might have a MySQL source code developer like me who might have a question why there is a contention in my source code. An application developer might have a question why my application is running so slow. A DBA might have a question why this particular table is so hard. So to answer all these questions, performance schema comes into picture. So if you ask me to define performance schema, I'll say performance schema is a mechanism to give user an insight of what is happening behind the scene when MySQL server is running. Okay, we introduced performance schema in MySQL 5.5. We introduced a new storage engine, we called it performance schema. We introduced new database which we called performance_schema, and all the statistics which performance schema collects are stored in the tables of this database, performance schema. The data which we collect during the runtime for MySQL statistics, running server statistics, is not persistent. So that means once the server is stopped, the data will be gone. And the best thing is we have provided SQL user interface to the user. So if user wants to see some statistics, he can simply fire an SQL query and get the data out of performance schema tables. Right. Let's understand the design of performance schema. So performance schema has two major parts. One is the statistics collection part, in which it collects the runtime statistics of running MySQL server. The other part is statistics reporting part. This is the part in which when a user wants to see some information from performance schema, he gets the information out of it. So let's say we have a MySQL server running. In the MySQL server source code, we have introduced a lot of hooks which we call performance schema instrumentation points. So when the control comes to these, the execution comes to these instrumentation points, the control is transferred to performance schema, and the statistical data is collected on the fly and stored into performance schema internal buffers. That's the statistics collection part from the bird eye view. Now let's say there is a user who wants to see some statistical information from performance schema. He can simply fire an SQL query to MySQL server, and this query will be passed and executed, and the data will be fetched from this performance schema internal buffers and presented to the user in performance schema tables. So that's the overall design of performance schema. Statistics collection on the left hand side, statistics reporting on the right hand side. Instruments and instrumentation. Let's understand this. So when MySQL server is running, there are a lot of activities which are happening behind the scene. So all those activities which we monitor in performance schema, we have given them a specific name. That name is called instrument. So an instrument is a name of a monitored activity. So this is a tree-like structure in which the different parts are separated by // and as you move from left to right, you will move from more generic to more specific part. Let's take an example to understand instrument. So these are the example of two instruments. The first one is wait/io/file/mysm/log. So what does it say? It says there is an instrument or there is an activity of wait which we are monitoring in performance schema. And what kind of wait it is? It's an IO wait. Now IO could be on table or file or socket. So this activity is for file IO. And what kind of file? It is MySQL log file. So the very first line, the very first instrument is monitoring any IO activity happening on MySQL log file. So this is the name of that instrument. The second instrument is statement/SQL/select. So this is statement instrument. What kind of statement it is? It is an SQL query. And what kind of query? It's a select query. So we are monitoring statement/SQL/select. That is, we are monitoring select activity in MySQL server. Like this, these are two examples of instruments. So in MySQL 5.7, which we released last year in October, we have 1,000 plus instruments. That is, we are monitoring more than 1,000 activities in MySQL server as of now. And all these activities or all these instruments which we are monitoring are stored into performance schema.setup instrument table. Let's see how this table looks like. So this is the example, or this is the snapshot of setup instrument table. It has 3 columns. One is on the left hand side is a name column, that is the name of monitor activity. The second column is enabled, which says whether this activity is enabled or performance schema is collecting stats for this activity or not. Third column is time. That is, if we want to get timing information of any of this activity, we can turn it on or we can turn it off otherwise. The very first is statement/SQL/select. It's enabled and it's time. That is, I want this activity, the statistics of this activity to be collected by performance schema, and I am interested in timing information as well. Right? The second one is statement/SQL_create_table. That is, if whenever this create table is happening on MySQL server, I want the statistics of that, but I am not interested in timing information of that activity. I mean, how much time it has taken to create a table. The third is statement/com/createDB. So I am not interested in this activity at all. I don't want timing information. I don't want it to be instrumented. Right? And the best part is all this configuration of enabling and disabling any activity you can do at runtime. So at runtime you can decide, oh, I want all these activities to be enabled and I want all these activities to be disabled. You don't have to restart your MySQL server for that. Let's see the statistics table which MySQL Performance Schema gives. So there are a lot of statistics table in MySQL Performance Schema. I try to divide them logically into different parts. So the very first part is setup tables. So we have setup instruments table, which I showed you in previous slide, where you can specifically say what activities you want to monitor and what activities you don't want to monitor. The second one is setup actors table. So in this table, you can specifically say for which user or for which particular host you want to have statistics to be collected. The third is setup objects table. Here you can specifically say for what all databases or for what all tables or stored procedures you want to have statistics to be collected. And we have consumers, we have timers. Timers basically keeps the information of the units of time in which you want to have statistics to be collected, maybe millisecond, microsecond, picoseconds. Then we have events table. So in performance schema or in MySQL server, we have these 5 events. We have transactions. A transaction could have multiple statements. A statement could go through multiple stages. The stages means so when a statement is executed, it goes through different stages. It goes through parsing, it goes through optimization, it goes through fetching table, opening table, sending data, close tables. All these are the stages. So when a statement is executed, it goes through multiple stages. When inside a stage, we go through multiple waits events. So suppose I am trying to read some data from a table, we have to take a log on that table. To take that log, we have to wait for some time. All those waits activities are also monitored in performance schema. And if at all a connection is doing nothing, I mean no queries are coming to the server, that's an idle connection. That also we monitor. Then we have instances table. So we have a lot of mutexes, we have a lot of read-write logs in performance schema, in MySQL server, and files, different sockets, conditions. We monitor all those activities and keep the instances of all those mutexes read-write logs. Then we have tables for table logs information. We have table for metadata log. We have tables for different table handles. We have tables for connection attributes using which a client is connecting to the server. We have types of connections, information. And in 5.7 we have introduced replication summary tables as well. So before 5.7, if you want to get the replication information, like you use show slave status command. to get the information. That information is ported into performance schema now. Then we have system variables and status variables as well. So before we used to do show status, show variables in MySQL, we can get that information performance schema now. And apart from that, we have many miscellaneous tables as well. And the best thing is this category, summary tables. So we have a lot of threads, a lot of statements executed on the server or being executed on the server. In this table, we summarize all those activities and aggregate the statistics and put them here. So we have summary tables for events. Events are transaction statements, waits, idle. We have summary table for memory allocation, which thread is using how much of memory, which user is taking how much of memory of MySQL server, all those information. And the summary table could be, the summary could be collected based on global or by thread, by user, by host. So you can say for a particular user, how much memory is being taken, for a particular thread, how much memory is being taken, etc. Now let's take a few use cases to understand how we can use performance schema to diagnose a real world issue. But before that, let me give you a glimpse of what we can get from performance schema. So let's say I started my MySQL server and I did update performance schema.setup instrument set enabled is equal to yes and time is equal to yes. That means I want to monitor all the activities and I want timing information of all the activities as well, right? Let's say I have two connections, client connection, connection 1, connection 2. The server is running. From connection 1, I started 3 transactions, and in that I inserted 3 values into table T1, and then I did a select. From connection 2, I started 2 transactions, and I inserted 2 values into table T2, right? That's all I did. The server, 2 connection, that's all these 2 connection did. Keep in mind, we did 3 inserts from the connection 1, 2 inserts from connection 2, and the last statement executed by connection 1 is select star, and last statement executed by the connection 2 is commit. Now let's see what we can get from performance schema for these activities which we did from different connections. So in performance schema, we have a table called event statement current. So this table keeps the statistics of latest statement executed or being executed by any thread. Let's see. So I can see from connection at 24, that is our first connection, and thread at 25, that is our second connection, the last statement executed is select, and here the commit. And the SQL text was select star from test.t1 and the commit. So and this is the time it has taken. So we can see at any given point of time what is the latest statement executed by any thread in performance schema. Okay, so I got the latest statement executed by any thread. Is it possible to get all the statement executed by the thread? So we have event statement summary by thread by event name. In this table, we get all the statements executed by any thread. So I can see from connection ID 24, that is our first connection, we have 3 insert statement executed. This is the time taken for these insert statements. And we have 2 insert statement executed by connection ID 25, and that is the time taken by these 2 insert statements. So I got last statement, I got all the statement by thread. Now how about if I want to get, doesn't matter from what thread the statements are coming from, I get the overall statistics of performance schema of MySQL server. In performance schema, we have a table called event summaries, event statement summary global by event name. So it doesn't matter from what thread the statements are coming from, it will aggregate the statistics. So we can see on the MySQL server, till now, total 5 insert statements have been executed, total 5 commit statements have been executed, and just the time taken by these statements. Okay, so now you know what all information or the glimpse of the information which we can get from performance schema. Let's go to the use cases. So let's say I have multiple queries running on MySQL server. So there are few queries which are long running queries, taking a lot of time. I want to identify those queries, and if at all I can get some information why those queries are running so slow. Let's go to performance schema. So we have event statement current table, which gives the latest statement executed. We have event statement history table, which gives us the historical statements which have been executed on any server. So in this table, I query give me all the statements which have been executed which are taking time greater than x. So x is our threshold. So if any queries goes beyond x, we say it is a long running query. So I get this information. That is, there is a thread ID 25 from this particular session. The thread is executing a select statement. The statement text is select blah blah blah, some long running statement. So this is the query which is running very slow. So I identified which query is running slow. Can I get some more information performance schema? Right, so I get select underscore scan is equal to 1. So it tells us for this particular query there has been a full table scan and no index used is 1. That means no index has been used for this particular query. So what shall we do? We should introduce the index on this particular table so that this select query can take an index into consideration and the timing information time could be improved. That's the first use case. Now let's take another use case. Suppose we have a MySQL server running in which a lot of statements are giving errors. So I execute a query on performance schema event statement summary by digest table. Give me all the statements which are running through error. So I get this information. So the statement create temporary table if not ... that long SQL text. It has been executed 1725 times. And out of those 1725 times, it has resulted into error to 1725 times. So this statement was never ever executed successfully. So this is the statement which we have to focus on and try to find out what is making this statement to fail again and again. And we get this information as well for performance schema. When was this statement executed very first time? And when was the last time this statement was executed on the server? So we can see the time span as well. Let's take the use case 3. So I am a MySQL server developer, source code developer. I am developing something and my particular session is not going further. It is stuck somewhere. So what to do? So I go to performance schema. So let's say my thread which I am executing is thread T1. I go to event waits current. Event statement current gives me information of all the current statement executed or being executed on the server by any thread. Event waits current gives me the information of all the waits event on the server by any thread. So I say, give me the information from event waits current where thread ID is equal to T1. Sorry. So I get this. From the object instance begin column, I see that T1 is waiting for a mutex A. So that is the reason why my session was stuck. Now if T1 is waiting for a mutex A, it is not getting it. That means somebody is holding mutex A. Now how to find out who is holding mutex A? So in performance schema we have a table mutex instances. So I execute a query on this mutex instances table and I see from the column locked by thread ID that mutex A is being locked by thread T2. Okay, so I found out who is holding mutex A. Now if thread T2 is not releasing mutex A, that means it is also waiting for something else, right? So I again go to the event waits current table and find out what T2 is waiting for. And I can keep on doing this until I find out I find the culprit one, the guy who is making all this wait cycle to happen on the MySQL server. Okay, event hierarchy. So as I said, a session could have multiple transactions, a transaction could have multiple statements, a statement could have multiple stages, and a stage could have multiple waits. So in performance schema, we monitor all those activities. And we have maintained this hierarchy as well. On the next slide, I'll tell you how this hierarchy is maintained in performance schema. So 4 events in MySQL server: transaction, statement, stage, and wait. A transaction could have multiple statements, a statement could have multiple stages, stage could have multiple waits. Right. Now, to identify a single instance of statement, stage, or wait, we have given them a specific ID that is called event ID. So there could be 100 statements or 1000 statements being executed on the server. We can identify those statements using the event ID. Similarly, there could be multiple stages, thousands of stages on the server. We can uniquely identify them using event ID. Now there is something else called nesting event ID. So the nesting event ID of any waits event points to the event ID of the stage event to which they belong to. That is, all the nesting event ID for waits events which are belonging to a particular stage will have the event ID of that particular stage. Similarly, all the nesting event ID of stage would point to the event ID of the statement. And similarly, all the nesting event ID of the statement will point to the specific event ID of the transaction. So in performance schema, if I get a wait event which is not going further, I can simply go and relate it to the transaction from which it is coming from. So I can see, okay, this particular wait, right? This particular wait is coming from which statement, or it is coming from which transaction. That's the hierarchy we have maintained in performance schema. Okay, so till now we have instruments available for IO operations. The IO could be on file, table, or socket. We have mutex instrumentation for mutexes, read-write logs, table logs, metadata logs. We have instrumentation for events, like I said, transactions, statement, waits, stages, idle event. We have instrumentation for stored program, that is procedures, functions, triggers, and schedule events. We have instrumentation for memory as well in 5.7, so you can specifically see which thread is taking how much of memory, or how much of memory is being used by performance schema itself, and many more instrumentations. Now let me give you a glimpse of what we have new in MySQL 5.7 that we released last year in October. So in MySQL 5.7 we introduced a lot of new instruments in performance schema. Now we have instruments for user variables which you set over the string prompt. We have instrumentation for transactions, memory usage. We have stored program, prepared statement, metadata logs, and we have types of connection instruments, the stages of InnoDB storage engine, replication summary table, which was from show slave status before. We can get it now from performance schema. Global and session variables and status. So all these new instruments we introduced in MySQL 5.7. And apart from that, we introduced a lot of enhancements as well in 5.7. That includes the digest size, which was hard-coded or fixed before. It is configurable now. In 5.7, you can specifically say for what session we want to have historical information. Earlier it was 0 or 1 for all the session. And the memory location for performance schema is scalable now. So earlier performance schema used to get all the memories upfront when the server starts. Now performance schema get this memory or allocate this memory as and when need arises when MySQL server is running. We have reduced the memory footprint of performance schema as well, and many more new enhancements which we have done. So in MySQL 5.7 we have 87 statistics table in performance schema, and we have 1000 plus instrumentation available or instruments available in performance schema. Right. And a new thing which we introduced in MySQL 5.7 is sys schema. Earlier it was known as PS helper, and that is performance schema helper. So sys schema is nothing but collection of procedures, functions, and views. And what all these procedure, function, views are? They are nothing but the many of common day-to-day use cases which DBAs use for tuning and debugging. So what this schema does is it takes information from performance schema table, it takes information from information schema table, club them together, get the meaningful results out of it, and present it to the user in formatted form. This is a very useful tool and very much talked about tool in the community, and we have received very good feedback about this tool. So you guys can go back and give a try to this tool. And that's all. That was my last slide. Thank you. Any question if you have any performance schema, I can take it now.
Is there any overhead in storing all this information?
Yes, so as we are storing this information on the fly when the server is running, some overhead is there, but that overhead is minimal. So last time when we did the benchmarking, I guess with the default instrumentation on, the total overhead was 5%.
So it's dependent on the number of queries I'm running on the server?
No, the overhead depends on number of activities which you want to monitor. You can set enable, disable on the runtime, right? So if you enable everything, the overhead will be more. So you can intelligently go and decide which activity you want to monitor. So the overhead would be minimal.
And we store all this historical information until I delete it, or like,
Until?
all the statistical information we store, it keeps on accumulating, or
Right, so it keeps on accumulating. So we have different buffers in performance schema, which you can, the size of those buffer you can specifically see from the command prompt or from the configuration file, and you start MySQL server. So once the buffers are full, then we start losing statistics. So we have performance schema status as well, where you can go and see if at all any statistics is being lost or not. So the lost counter will start increasing. The statistics is lost. So to overcome that, we have this scalable memory allocation now. So for few buffers or for good number of buffers, we have this scalable memory allocation where you don't have to specify the size upfront. So you can say automatically decide the size and automatically keep on increasing the size. You can do that now in 5.7.
At the moment you restart the database, all of the things that exist in the performance schema is gone, right?
Yes, they are gone.
So
they are not. Yeah.
If we, because I'm coming from the Oracle side, the Oracle database, normally we can have something like stored performance, right? So we can go back to, in the past and look at the historical data. So is it possible to do this?
So the only way possible for this is you have MySQL server running, you have all the information, statistical information, you can dump those information or dump all the tables into your flat file or into your database. Because MySQL Performance Schema does not keep any information, because this is all this statistical information is in memory, not on the disk.
Then how does it, if we enable but the time we set to off, what's the difference? I mean, what will happen?
Pardon?
Because there's a enable and time, right?
Yes.
But if we enable but we set off to the time.
Right. So if you enable it, it will take, suppose for select statement you have enabled instrumentation, but you said timing information is time is equal to off. So you will get that so many select statements have been executed for this particular thread, from this particular session, for this user. But how much time it has taken to execute that, you won't get that information. You will get null.
Mayank, can I add to your answer?
Yes, sure.
Okay. So basically, with this is performance schema. If we have another product called enterprise monitoring. So this monitor is just if you're aware, if you've been doing the Oracle database last time, right? That means you're familiar with OEM, enterprise manager.
Exactly. Yes.
So enterprise monitor is just like that. So it will collect all the data from performance schema and store it in the repository. And that way you can have that data.
So you have to use the OEM.
Sits there, things like that, yes. It's just the same in Oracle database.
Yeah, that's all the time. Yeah, thank you very much.
Thank you.